we were understanding about all this concept in which we understood meaning of reference point, meaning of rest and the motion, distance and the displacement, how to calculate a speed, how to calculate the time, how to calculate the distance. You can calculate a speed, time, distance in your question according to need. What is the question saying? If a question is saying calculate time, then you will apply this formula. If a question is saying calculate a speed, then you have to use this formula. A speed is equal to distance upon time. If a question is saying calculate find what is a distance in your given question, then you have to use this formula. So according to need, what is the requirement, that you will have to see. We understood meaning of a speed with example, and we saw what differences between distance and displacement, in which we understood that distance is a scalar because of it has magnitude, displacement is a vector quantity because of it has both magnitude with the direction. Distance only can be only positive, not negative, not zero, but displacement will be negative, positive or zero. Okay, here unit of a distance is what, meter per second, and meter per second is a for also displacement. Okay, there is nothing change. Clear? Yes sir, to cover distance it takes a times, to cover displacement it takes a times. That's why here second came, and second is a SI unit of time, as you know. Okay, so I think we were understanding this. Now we should move on ahead of this. So here we will understand what is average speed, how to calculate average speed. We are going to understand. Now. Next is average speed. We saw that speed is equal to distance upon time. It will be for same. It will be same for average speed, but there will be something change. Do you know what is instantaneous speed? Instantaneous speed. Do you know what is the meaning of instantaneous? Instantly. When we say instantly. Meaning of instantaneous is what? Current. What is a current? For example, instantaneous speed. So you are telling that this is a current speed of our vehicle. So instantaneous, which means current. Okay, something is current. A speed, current speed is this much. So okay, right now is what? Is current. Okay, I'm not talking about electricity. Is that no? Right now is what? What is a speed right now? That will be what? Instantaneous speed. Okay. Now here we are understanding average speed. Average speed. Same distance upon time, but as I said you, there will be something change. Speed, average speed, total distance upon total time taken. Now we will break down it here. To calculate average speed of something of object, we use this type of object this type of a formula. Formula is a total distance. Total distance. Okay. It was for also a speed, I think. Yes, for also total time taken. Total time taken. What is a change? What is a change? Here we are saying average speed. It means a speed is a changing. A speed is a changing. It is what non-uniform. If a speed is changing, so it will be non-uniform motion. We understood. We have understood meaning of uniform motion, non-uniform motion. Here a speed is changing. It is saying sometimes a speed of our vehicle is low, sometimes high. So it is what a speed is changing. Okay. If a speed is changing at a uniform rate, then we use this formula. If a speed is changing. Okay. But here I would like to take what a speed, so that we can understand what's the difference between them. We should not have confusion. Okay, that's why I am taking a speed with this average speed. What's the difference between average speed and a speed? Are both same or not? If yes, then how? If no, then why? Why like that? Okay, we will avoid confusion from this discussion. As you know, formula of a speed is what? I think distance upon distance upon time. That's it. And here we are writing. I have written what total distance, but here total word is not there. Total time taken, but here word total is not there. This is a difference, but exact difference is what? Here, our difference between them starts from here. Here distance will not be changing. Distance will not be changing. It will tell you complete distance. It will tell you complete distance in this. Okay. For example, an example is giving you a distance which covered by vehicle. For example, 15 kilometers upon time. How much time? You can say not 15, 5 kilometers. You can say 5 kilometers, and you can say within 10 minutes. Okay, within a 10 minutes. Now from this we are getting a speed. What is a speed? What is, otherwise you can say what was the speed of that vehicle? If distance covered by that vehicle is 5 kilometers and time taken by that by that vehicle was how much? 10 minutes. Then a speed, what was the speed of that vehicle? From this we can calculate what to find a speed. So as you know, a speed will be what? 0.5 kilometer. I think it is a meter per second. Yes, meter per second. Meter per second. Okay. Meter per second. So vehicle was moving with a speed of 0.5 meter per second. But when it comes to a speed was increasing, then we will take what? Initial speed V as a final speed. Okay, we will take u as a initial speed, v as a final speed. Okay, what was the initial speed of that vehicle and what was the final speed of that vehicle? We will take this. Then we will divide after adding both speed. We will divide by 2. You can see. Here we are taking different speed because of a speed is changing. That's all. If a speed will not be changing, if a speed were not changing, then we would not have taken what u plus v. No, directly we would write what s upon you can say, okay, to distance upon time you can say. So here a speed is changing, that's why we are taking initial speed plus final speed. So initial speed, what was initial speed, what was final speed? As you know, at the initial speed it increase, at the final speed it decrease. It is a very nature of vehicles. Okay, so here from here you will get what is average speed. Here we are getting fixed speed. Here we are getting, from this we are getting fixed speed, but from this we will get what average speed. We can assume that this was the speed of this vehicle. We are assuming by calculating using this formula. So here average word is there. There is a word average. So average, here we are not confirmed that this was, so this speed, this was the speed was of this vehicle. Here we are taking average speed. Okay. Now do you want to know exact meaning which exists in real life about this? So here, as you take your bike and you are going to your college, you have taken what? You have taken bike to go to your college, and you start. You will realize, you will observe what? Sometimes you will decrease a speed of your vehicle, sometimes you will increase a speed of your vehicle, but sometimes you will decrease a speed of your vehicle. So when does it happen? Tell me, when will it happen? So something is coming in front of you, then it will happen. Something is important work and you remembered immediately, then you will stop. So yes, something will come. There are traffics and roads where you are going. So a lot of things that come in front of you while you are driving. So then you decrease a speed of your vehicle. Okay, like that, and you take turns, a lot of turns. That's why average speed, I think average speed, it should be vector. But we will understand, is it vector or not? I will tell you later. Here, so that's why speed is increasing, decreasing, speed is changing because of anything can come in front of a person who are driving. Anything can come. Okay. So here a speed is changing, a speed is increasing, a speed is being increased, a speed is being decreased. So it is what? It is acceleration. It is what? Acceleration. I will tell you meaning of this with example, but little information regarding it you can understand from this discussion. What acceleration is just what it tells you changes of a speed of a vehicle. Who will tell you? Acceleration will tell you. Okay, you applied what accelerator. It means you are increasing a speed, you are decreasing a speed. When you apply accelerator is found in your vehicle, which is a device, and it is used to increase the speed or decrease. Okay, that's why this device helps you, okay, to decrease a speed or increase to increase. Clear? So acceleration is just what it is saying that a speed is increasing, a speed is decreasing, is what acceleration. In one word we say acceleration. Okay, here meaning of acceleration is coming for discussion of or understanding of average speed. Here directly it is saying a speed is changing. It means it can increase, it can decrease. Okay, that's why we have taken u plus v. Initial speed can be something else, and final speed can be something else. Let's just say initial speed is at middle level, and final speed is what low level, because of person wants to stop his vehicle. That's why he applied lower speed. So, did you understand? Did you understand? Clear? When it will come to average speed, then you will take what u plus v upon 2. So I think we have understood. So what's the difference between them? Difference is what? Here we don't see what was initial speed, what was the final speed. We see what exact speed. So here can we say that speed was constant? Speed was constant. And in this case we cannot say that speed was constant. Speed was constant. It can be constant, it may be constant, but most of the time often it will not happen that speed is at constant. Okay, for speed constant, this is and time will be same. Now here, what is the SI unit of what is the unit of average speed? Same, meter per second. Nothing is changed. Meter per second. Clear? Nothing is changed. Always remember, a speed is considered as meter per second, but odometer, a speedometer will tell you a speed in this unit, with this unit, but odometer will tell you total distance covered by vehicle within a time. So it will tell you what with the unit of kilometer per hour. Okay, and this is in your too. It will be used always, and this will be used always. Okay, we cannot change this at all, and also here we cannot change this at all. Shall we take next concept? Yes, we should take. Next is velocity. I can say velocity will be vector. Let's see how velocity. Meaning of this is what? Now we are breaking down it. We are understanding velocity. Let's understand this. Velocity. How to calculate velocity? Velocity is equal to distance or displacement upon time taken. Okay, time taken by object. Displacement is coming. It means we will not take a distance. Distance is for us average speed. Okay, for average speed. But velocity. I think average speed will be what? Average speed will be a scalar. But I will tell you completely right information that average speed is a scalar or not. Later I will tell you. But confidently I can say velocity will be a vector because of displacement is coming. And displacement is coming, it means it will tell you direction. So here meaning of velocity is what? Meaning of velocity is a speed with direction. A speed with direction. Meaning of this is what? A speed with direction. And that's where it becomes vector. That's where velocity becomes vector. Okay. That's why velocity is said as a vector. It is a vector quantity because of it is showing direction. That's why it is showing direction. That's why. So are you clear that meaning of velocity is what? It is just a speed with a direction. It will cover a speed, but it will take a turn. No. Are you getting clarity? Are you clear that it is saying a speed with a direction? But in the discussion of average speed, that average speed was not telling that a speed is with a direction. So of course we can say a speed is going in direct. In the case of average speed, vehicle was going in what? In a straight direction. In a straight. There was not any kind of a direction. But in this case, this will show you direction with a speed. Okay, with a speed. So it's a difference between velocity and average speed. Velocity and a speed, you can say velocity and a speed. speed. Can you say what is the difference between the distance upon time? Here we were taking distance. We were not taking any kind of a direction for the speed. Okay. In the case of velocity, we are taking displacement, and displacement, as you know, it tells you direction. It gives you direction. Okay, and it covers the distance. I'm not saying total distance. Okay, it will tell you shortest distance with a direction. Clear? So of course it will take a speed. Displacement will take a speed. But how much time was taken? And how much distance of displacement? How much displacement was covered? If velocity is changing, this is a simple velocity, displacement upon time taken. But for average velocity, it means velocity is increasing sometime at a times, or it will be decreasing. Then in that case, you will use displacement upon total time taken. It seems both equal, but what's the difference? Difference is what? Displacement we will take as a u plus v, where u will be initial speed, v will be final speed, upon 2. Clear? Upon 2. And here we will add total time taken. So if velocity is changing, then you will apply u plus v. If velocity is not changing, just apply what is the total displacement. Just use this. If velocity is changing, then you come in category of average velocity. Then you will use u plus v upon 2. Are you clear? So what's the difference between them? It has a distance. It does not have a distance. It has a displacement. For average speed, it also takes u plus v. Now you are observing what's the difference? Average speed and what's the difference between average speed and average velocity? I know both seems what equal. There is another difference you will be saying. But difference is what? Just a distance. Just a distance. Okay. Difference will be what? Distance. So in this case, distance word is coming, but in this case, a distance word is not coming. This is a major difference between them. Okay. Distance, direction impacts heavy. If direction is not with a speed, and if a direction is with the velocity, then there will be impact of a direction more. So that's what's the difference? It takes a direction, but it does not take any kind of a direction. This is what difference between. Clear? So what if I ask you average speed, tell me a speed, how to calculate a speed, then you would say distance upon time. You would not think, you don't need to think what displacement in the case of a speed. So a speed, distance upon time. Of course, a speed will take time. Average speed will take time. Velocity will take time. Average velocity will take time. Okay. Time will come. I think almost for a lot of main words. Here, for average speed, u plus b. It is showing that u plus b. initial speed, final speed. It means if a speed is changing, then we will take what? U plus b. U plus b. U is a final speed. U is a initial speed. B is a final speed. Here a speed word I am saying. Okay. Now next thing is what? Velocity. Velocity. How to calculate velocity? So here instead of taking distance, we will take what? Displacement. Because of we are taking velocity. We are not taking a speed. We are not talking about a speed. We are talking about velocity. Velocity is a vector quantity because of we are taking displacement. Displacement is the word. Displacement word is there for velocity. So displacement upon time. Displacement upon time. Clear? Clear. Clear. I think clear. Clear. That's how you will use this kind of formula according to it. Here velocity was changing. That's why if velocity is changing, same you will apply u plus b upon 2. But here direction word will come. Shall we take next concept? Now next thing about the acceleration. We will understand meaning of acceleration with the full focus, with full concentration. We have this next topic, acceleration. I told you a little information about acceleration. Can you tell me that information that I have told you? Here again, I would like to repeat the same meaning of acceleration. I was telling you about the meaning of acceleration. It is just what it is just what increasing a speed or decreasing a speed. Okay. Here, acceleration it tells what driver is increasing a speed, driver is decreasing a speed by applying accelerator. By applying accelerator. So acceleration is a word which is coming. Then we have to make sure that yes, somebody is increasing the speed of a vehicle, somebody is decreasing the speed of a vehicle. So there will be what changes of a speed, or you can say velocity. Velocity. So instead of taking a speed, you can take what velocity word, because of acceleration is a vector. Okay, acceleration is a vector. Clear? Acceleration is a vector. It will have a magnitude. So how to calculate acceleration? Acceleration, just whatever is a change in velocity, and divide that by time. Divide that by time. So here you can see time is coming again and again. It came many times. It came many times. That's why time becomes important in discussion of motion lecture. Okay, time will come. Okay, change in velocity. It means what? Displacement is a change. No. Displacement. It is the same what? Velocity. So I think it is also what? Unit of acceleration is also what? Meter per second. So here velocity is increasing. Velocity is decreasing. Okay, decreasing. That's why change in velocity upon time is how to calculate acceleration. Okay. We will use this formula in questions. From here, you just understand a little information regarding this. It is what? Acceleration is a device, you can say. It is also device which is found in vehicle. It is used to increase a speed or to decrease a speed. That's why accelerator device is used. Okay. So of course, when we will increase the speed, it will take time. When we will be decreasing the speed of a vehicle, it will take time. It will take time. Now shall we understand the meaning of uniform circular motion? Uniform circular motion. Here word is coming what? Motion. Circular. It means a object is moving in circular shape, like that. So object is here and it is moving. If a word uniform is coming, it means motion is a constant. Motion is a constant. Okay. A speed is not changing. A speed of this object is not changing. That's why it is a uniform motion. It is in motion, but a speed is a constant. A speed is a constant. A speed is a fixed. It is also telling you. It can tell you that speed of this is let's say 5 meter per second. 5 meter per second. So it is a constant. After few seconds, after 5 seconds, after 10 seconds, a speed of this vehicle will be same, 4 meter per second. 5 meter per second. There will not be same. And word is coming what? Uniform motion. Uniform. That's why I'm telling you. Clear? So something is moving in circular motion, not in straight. So it is moving in circular shape. That's why we are naming it as a uniform circular motion. You can see this is an example to understand it. This is object and it is moving in circular motion. That's why. And if word is coming, what it is telling you, a speed of this vehicle will be constant. There will not be any kind of a change in motion. Okay. One more. What about non-uniform motion? What about non-uniform motion? Can you tell me what will be the difference between them? Hold on. Non-uniform motion. No, non-uniform circular motion. Circular motion. Clear? Circular motion. It explains that somebody, you can just take object, an object is moving in circular shape. We agree, we agree that an object is moving in circular shape like that. But a speed of this a speed of this motion can be increased, a speed of this motion can be decreased. It is what that is what is non-uniform motion. Motion is acting, but motion is in circular shape. Motion is in circular shape, and a speed of this motion is not constant. It is increasing. It can be increased. It can be decreased. That's why we are saying this motion is non-uniform motion. And one word which specify it, what is circular. Motion is in circular shape, and the speed of this motion will be non-constant. Okay, there will be changes of a speed in this motion. So are you clear difference between it? In this motion was constant, but in this motion was not constant. Okay, in this speed was not increasing, speed was not decreasing. In this speed can be increased, speed can be decreased. Clear? I think we have understood as acceleration. Let's see some graph based on motion. Some graph based on motion. I am going to draw graph. With the help of a graph, distance can be represented, distance can be observed, time can be observed. Yes, with the help of a graph. And someone can interact with the graph. What is the distance with this time? What is the time with this distance? So graph will tell you easily and effectively. Do you want to see? Just let me draw. Just let me draw. uh, it is considered, this line is considered as x-axis, this as y. This is known as a reference point. Reference point. Here shall we take it this line as a tan line? 1, 2, 3, 4, 5, 6, 7, 8, 9. Clear? 20, 40, 60, 80, 100, 120, 140, 160, 180. This is a graph. This is how graph is drawn. One line is axis, another line is y axis. Now we are considering this line as a time. It will tell what a time. Now it is not fixed that this line will be for time, for telling time. No, you can consider this as a distance. It depends on you. It's a choice. It's a choice. Okay. Now we are considering this y line as a distance. It will be telling us distance. Okay, distance. 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 Now here I am going to draw a curved line, not a straight line. Clearly. So remember, this will tell you time, this will be tell you distance. 20 is a distance, 40 is a distance, 60 is a distance. One is what you can say in hour, you can say in hour. Yes, in hour. In hour. 1 hour, 2 hour. Here we can write minute if you are considering these numbers in minutes. Then I considered these numbers in hour. 1 hour, 2 hour, 3 hour, 4 hour. Like that we read 20 kilometer. Yes, you can write this is what kilometer per hour. Okay, kilometer. So 20 kilometer, 40 kilometer, 60 kilometer. That's how we read. That's how we read. Now I am going to draw a curve. Now a vehicle starts moving. A vehicle starts moving from reference point, from zero. Okay, a vehicle start okay, a vehicle start moving from reference point. It stops where? Let's say here. Okay, let's say here, this point. Vehicle started moving from here to till here. It covered how much distance till here? Can you tell? So as we know, these are distances, these are time. So here till here a vehicle covered 40 kilometers. It covered how much? 40 kilometers. One point you are clear. Now what about the time? Okay, this vehicle covered traveled with a distance of 40 kilometers, but how much vehicle took time? So distance covered by this vehicle is 40, and here it took 1 hour. 1 hour. 1 hour. Finally, we can say a vehicle covered 40 kilometers within 1 hour. Within 1 hour. So that is how we find. That a vehicle covered this much distance with this time. within this time. That is all. One more. It starts again moving from here to till let's say here to till here. So I want to know distance from here to till here. From here to till here. You would say this is 100. This is 100. You will reduce. You will subtract 100 minus 40. You will get what total distance, which is a 60. Which is a 60. 20, 40, 60. 60 kilometer. From here to till here, the same vehicle covered 60 kilometer. Within how much time? So from here to till here, 1 hour. Only 1 hour. Within 1 hour again. So here you can see time. Now from this you can tell me till here you can tell me what is the motion, what a type of motion. Here this is non-uniform motion. This is what? Non-uniform motion. Because of some one thing is changing. What is that thing? Distance. Distance is changing. I know a speed is the same. A speed is constant. But distance is changing. Sometimes you will realize that distance is the same, but time will be changing. Then we consider that type of motion as a non-uniform motion. So from here, did you understand? This is a motion, but what kind of motion? Question is what kind of motion is this? So you will say non-uniform motion because of distance is changing. Okay, I agree. Time is the same, but the distance is changing. That's why I am saying it is a non-uniform motion. Yeah, like that you would say. Now, what else? If distance were not changing, time were not changing, then we consider that motion as uniform motion. Clear? So from graph, non-uniform motion, any kind of motion can be observed from graph. Okay, from graph, and we express this which is in graph. We express this in mathematic way because reason is that it will not be possible for a lot of question. Okay, we will not be drawing again and again graph. That's why we apply what mathematics way. Yes, to understand you can use, and the uses of this are more in real life. Okay, so our main point is to understand. So it covered from here. Now one point, not from here till here. How much this covered? You would say 100 within I think 2 hours. 2 hours. Okay. So till here, from here to till here, you would say 100 kilometer. 100 kilometer. Okay. Again, you are saying 100 kilometer. But within how much time? You would say 1 hour. 1 hour. You can see what you can see. Now time is changing. But distance is not changing. From this I am saying from this. In this you can realize what time is changing, but the distance is not changing. In this we were realizing that time was what? Time was not changing, but the distance was changing. Yeah. But in this we are realizing that time is changing, distance is not changing. So we will consider it as a non-uniform. We will consider it as a non-uniform motion. Clear? Now, from here, can you tell me? From here, can you tell me? From this, can you tell me you will understand that something, this vehicle was in rest, not in motion. You will understand from this. From this, you will understand, you will observe that vehicle was in rest, not motion. It is telling you that time is passing from this, from this. Time is passing, isn't it? Time is passing, but vehicle didn't move at all. From here to till here, this vehicle didn't move at all, but time was passing, and it is a definition of object is in rest. Clear? Clear? So can we say, in this example, vehicle was in rest. In this example, vehicle was in motion. That is how we can understand a lot of things only from graph. Only from graph. Clear? Did you understand something? Shall we move? Now next, something else. Something else. For example, you have given this type of slope. Slope is what? This is slope. Okay, curved slope, like that, curved slope. This is a straight slope. Where now we are understanding what is a slope. What is a slope? Here, to find out the slope of something, let's say a vehicle curved this, okay, this, and here, okay, here. To find out slope is just a speed for a distance time graph. Here, slope is just a speed. Here, we will take this distance and the time. As you know, time is represented by t letter, and the distance is represented by s. So here, this is what we want to know. What is this slope? What is this slope? And here, can we say s1, no, s2 minus s1, this minus this one, and upon t2 t1, t2 minus t1. Clear? Now here we are understanding what changes of change of speed upon time, change of speed upon time. So little change. For little change, we apply what? Delta. We apply delta for little change. We apply delta, okay, and here is we apply delta time. Speed is increasing with respect to time. So here, can we say Now exact meaning of a slope I would like to explain here. It will tell you, it will tell you a speed is increasing. A speed is increasing with respect to time. This is what is exact time. Now I would like to extend it. So here it is telling you what uh, this delta is changing, is changing with respect to time. When a speed will increase, then time will increase. It is universal truth, as you know. Yes, a speed will increase, it means time will increase. So can we say a speed will depend on time? A speed is a depend on time, but time will not depend on a speed. Of course, it can alone, but a speed will not be alone. It will take time. Okay, as you know, a speed takes time, distance takes time, but time cannot. Yes, time can take distance, can take what a speed. It can take. It cannot take a distance. If time is not taking distance, it means something is in rest. But a speed of something will not be in a rest. Will not be in a rest. It is making nonsense. So if something is moving, it means that time, that object is also taking time. So can we say speed is a speed is a depend on time. It is a taking time. That's why we are saying when a speed will be changing, so of course it will be taking time. So a speed is increasing, a speed is changing with respect to time. It will take time. Let's say from here it from here to till here it took 2 meter per second. It took 2 meter per second within a 1 second. Within a 1 second. So of course, can we say 2 meter per second upon what? 1 second. Upon 1 second. So that is how we are understanding that this vehicle took this speed, but within 1 second. Within 1 second. So of course we cannot say that it took this much and the time was nothing. No, it will not make any kind of sense. Clear? So it tells you that upper denominator is a depend on numerator. Numerator will not depend on denominator. Okay, no. Numerator is a depend on denominator. Denominator will not depend on numerator. Clear? This is meaning of the slope. Delta means a small change. A small change. Even we will not be able to realize what is the change. Now next thing I would like to explain, which is very interesting. We were understanding meaning of a slope, and related to this I would like to explain something else. Something else like that. Like that, okay? Like that. This is a given slope to you. We are understanding what kind of slope can be there. If slope is increasing, we would say this is a positive slope. if a slope is increasing, you can see from here it is going like that, okay. It is going like that. Now you are clear to say that it is increasing from here. Now if slope is increasing upward, okay, if a slope is increasing like that, we would say from here to till here, it is what? This is what? Positive slope. Okay, this is what? So you can say this is a positive slope. Positive slope, okay. Because of reason is that it is increasing, line is increasing. Now, if slope is a constant, if a slope is a constant like that, slope is in a straight line, okay, in a straight line, then we would say that it is what? Constant slope. Slope is nothing, slope is 0, you can say. So constant, you can say constant slope because of nothing is changing. Yeah, time is changing, time is passing, I know, constant is. Okay, so if a line is in straight, we would consider that line as a constant slope. Now next, if this, it is coming like that, if a slope is decreasing, we would consider this kind of a slope as a negative slope, clear? Because of it is a decreasing, that's why it is a decreasing, clear? So these were what? These were slopes, nature slopes, you can say. Nature of slopes. These were nature of slopes. Clear? I hope you are clear. First, slope can be positive. Second, it can be negative. It can be 0. And we were understanding what? We were understanding in meaning of a displacement. Displacement can be positive, negative. Displacement can be positive, negative, or it can be 0. Same here, you are realizing what? Slope can be positive, it can be negative, it can be 0. Yes, same thing is coming. What? It is increasing, decreasing, and it is at constant. It is at constant. Clear? If positive, negative, 0, these are coming, it means it is telling you direction is there is a direction of a slope. There is a direction of slope. It is in straight direction, it is upward direction, it is a downward direction. Okay. Clear? I think this will be, that's all till here.